Okay, and share my screen. So let's continue our lecture. So uh, can you can you see the screen I shared?
Yes, we can see the screen.
Okay. So in the morning, we have already registered in the climate data store, and we already get the API key, right? Now we are gonna doing some practical exercise based on the Python course. So first of all, we need to install some necessary Python libraries, what we will need in the following analysis. So because I don't know if you have ever used the Python language, so I'm going to do a very brief introduction about the libraries. So what does the libraries, what is the libraries? You can consider it's like a toolbox. It's already written by the other community or by the other researchers. So they put all the functions, put all the algorithms, and put all the things inside the packages. So what we need to do is just to install it and to use their functions. So we don't need to build our own code and build everything. So we can use some already exist libraries. What we need to know is that what we want to do. So once you know what you want to do, you can search which packages may be useful for you. Then you can install the packages. So here you can see, so here is a cell. As I mentioned in the morning, here is a code cell. So for example, you add a code cell here. It will look like this. So it's an empty one. And this is what I already wrote. So we can delete this one. You can see here it's like a button, which like a play button. So once you click on this button, it will run the code in this cell. So just by a click. Let me explain what's the code in this cell. So in general, here is a function that means we will install some libraries. So this is the function in Linux we use to download the libraries into our notebook. So in general, in this part, the quiet means do not output all the details about the installation. So this part, you cannot modify this part. So, but the part after the quiet, it's all the names of the libraries we will use in our later sections. For example, the CDS API. So you can guess from the name. It's the packages that we will use to access the CDS API. So this one actually you can also find in the Copernicus data store. So it's the official library. It's the official library here provided by this organization. So here you can see every detailed functions, descriptions, everything here you can find about these packages. So you can click on the docs. Click on the docs, it will give you a very detailed description about what it can be done by using these packages. And in general, we will use this function. It calls the EarthKit data. So it will allow us to visit the data store through our Python codes. So here, they will also give you some quick start. For example, here they also show the codes. You can just copy their codes into the code cell and try to run them. So, and also they will tell you how to install it. So everything you can find in the official documents. But here I'm not gonna to move this here. I'm not gonna to detailedly introduce every packages because for every libraries, they provide so many functions and they can do a lot of things. So I cannot introduce everything for you. But in general, I can introduce what is useful, like why we need these packages in our analysis. So this one is for the climate data store. This one is to download it. And these two, so the CF grid and the NetCD4. These two packages, these two libraries is what we need to deal with the data structure called NetCD4. It's in general the formal template of the OpenSets climate data. So you will see in the later section what this type of data set looks like. So it's a data structure. So we will use these two specific libraries to deal with these data structures. And the NumPy is a very famous one for the mathematical calculating or dealing with the series list. And also the Xarray is similar to these two. So it's specifically for dealing, for read and analyze the NetCD4. And also for the MatPy is what we will use for calculate the wind speed. Because in this library, they provide some functions to calculate the wind speed directly by reading the NetCD4 data. And these two, the UltraPlot and the CattlePy, is what we will need to visualize our data set. So we can use these two libraries to easily produce very nice figures and also maps. And the last three is what we will use to download the data from the other URL, because I already pre-download a data set for you. And what you will need is to use these three packages to load the data from the web page into the Colab. So if you are not clear about what these packages, don't worry, because we will use it in detail in the later sections. So I'm just give a introduction. So now let we click the run this cell. We will going to install all these packages. So I encourage you to run the copy of your notebook following my steps. Like when I run the cell, you can also click your own copy because it will, you can see what will happen and it will show the same result. So here you can see they are downloading the libraries from their source and comparing it. So we will wait it to finish. Like here, they will show how long, like the time for this cell is running. So it's already 40 seconds. Let's wait a bit. Okay, it's ready, so 50 seconds. So now we already install all these libraries into our environment, into this Colab notebook. So now we can import these libraries, because only if we import these libraries, the codes can know how to use it. Like it's an easier way to explain. So we need to import all these libraries into our working environment. So for example, here you can see we import the EarthKit data is what we downloaded before. And here we use the import function. It's the Python function to import the libraries. And here you can name the libraries as you want, what you want. For example, here we name it as EKD, but you can change it whatever. You just need to keep in mind it represents this library. For example, I can rename it as the Earth kit. Okay, Earth kit. It works the same, but it's just easier for EKD because in the following sections I use it. Yeah, so in the following sections, when we want to use the functions from this kind of libraries, we will not write their original name. We will write the name what we define. So the EKD, the NP, the XR here. So as I mentioned, you can change the part after the S as you want. You just need to know what it represents, what the library it represents. So we can click running. So we will import all these libraries into the environment. So it's very quick. Then we will start to load the data from the climate data store. In this lecture, I will teach you two ways. One, so sorry, is there any? Okay, nothing. So if you have any problems or questions, just interrupt me, okay? So now, we will try to load the data directly from the CDS data store. We will not download it, but load directly from the CDS. So here, for example, you can see the code cell here. What does this mean? So don't be afraid of such a long grid of codes. And how can we write this code? And what does this mean? I can show you. So for example, in this morning, I already teach you how to select the data product here. And so now we select the error file. Okay, single year. And when we collect download, reanalyze, and component, everything, and we select 1 year, and we select all the months, select all the days, select all the time. And then here, for example, we can select a region. If we use the whole available region, they will provide us a global data set. But we can only download a specific region, what we are interested. So for example, here we are interested in the area around the Strait of Messina. So we can provide the latitude, so from the south to the north, and the longitude from the west to the east. So let me check. It looks like the longitude is from 13, so 13 to 18. The longitude and the latitude is from 36 to 40. So you can see, after we select all these things, if we download here, I told you we submit, right? Submit so I need to log in. So wait a second. Because we changed the classroom, I need to download. Sorry, I just registered this morning, but I already forgot the password. Let me. Oops. Okay, let me reset the password. Sorry. But sorry, wait a second. But I think you are able to log in through your account. Let me check my account. Let me try this one. Try to log in. Okay, here we are. Finally. So here, after we accept the term here, if we download by the click, we can click here, like we submit the form. So if I click the form here, so it will submit this kind of request to the system. And also it's queued. Let's wait, it will change later, but I will show you another way because we are not going to download the data by the click. Because there are some, for example, you can see here, we can only download by year because there are some limitation of the size of the data you are requesting per time. So it's very hard if we click every time. So we are going to use the codes to download the data. L5. If we cannot find, we can also search here, verify already, and then they will show it. So here, download. So click here. So it's the same. After we click everything, so the region I didn't change. So we are going to download the data format. It's called netcd4. So we select netcd4. You can see the request size. It's already red. So we only select 1 year. So every time if we click here to submit it, we need to download every year and then click here to download. So it's very time consuming and not very easy because you need to change the box, select a different box every time. And here, if you click here, you can click show API request codes. So it will show you a format of the codes, kind of a template of the codes, how to download the data by our selection. So it's the same page of the download. So for example, here, after you accepted the term of use, only if you have accepted the term of use, you can download, right? Did you accept this part? Then it will be a part called API request, right? You can click here, show API request code. So they will give you a template based on your selection. For example, here I selected the name of this dataset is reanalyze. And we request the reanalyze. We request these two variables, and we request the year of 1941. For example, we request all the months, we request all the days within all the months, and we request each time hour, and we choose the data format at 1964. So we can write the code as this template. So also here, I already provide you a template of this data source. This is the format when we using the EKD, when we use the EarthKit. So you should know this EKD represent this package. So we call the function from these libraries, and we visit the CDS dataset, and we are request the reanalyze dataset, and we are requesting these two variables, and the product type is the reanalyze. So exactly the similar format as the code show here. So if you are not clear how to write the request code, you can first by click here, and then you show the API request, and then you can modify here. So you can modify it accordingly based on the selection. So for example, here we are going to request the year of 2024. So last year, we will have a look of the wind speed date of today, last year. So the 16th of October, the month is October, and the day is 16th. And we will request the data for each hour, so for 24 data, and we will request the area of the Strait of the Messina. So, but so I just select in the map. Yeah, because you can define the area as you want. It's just based on your which part of the region of your interested. So, for example, I can change the longitude and latitude. So the data what I get is the data in the area I define. So you can modify this area. I just give you an example because I just use a triangle close by the island. Like the triangle will look like this as the map here. So it's the area. So from 13th to 18th longitude, from 36 to 40 latitude. But you can make it like as smaller as this or even larger based on the area you select. Okay, so we back here. So the same, we click this running. So the code will be running. So you will see this empty part because here we will need to insert our API URL and the API key. So first, for the API URL, we will leave it default. Yeah, sorry. Your code has an error. So what's the error? Respect. Let me have a look. Because you didn't run the previous cells. So you go to here. You go before, I think you didn't. You should run this one. But if you run this one, because but every time I come in, yeah. Okay. Yeah, because every time when we reopen this notebook, we lost the environment. So every time when you reopen the notebooks, you should follow in this process. Like first, you need to install the libraries, and then we import it. And the next step, we will run this one. So let's wait. Can you run these cells, Bernardo? Yeah. I understand. But why we look only? But why they are not here in chat? Yeah, but the participants, they are not. Yeah, they are not here. I don't know why. Yeah. Because I'm not sure they are connecting or not. Strange. At the beginning, they were here. Okay. Because now I cannot, also I cannot hear them, neither. They are not here. Maybe let me interrupt the. What if I write to them? Um, so let's wait for you. Strange.
So here, Fernando want to go to what? Fernando want to go into the world.
So
So
he
he cannot attend. And let us say I have to go some.
okay.
Yeah, they didn't attend only. They didn't attend. You
Okay.
can go on.
Okay. Because I didn't notice
No.
they already disconnected.
Is it their fault? They want to go. I don't know.
Okay, so
Only me and this.
okay. So, but we still need to record it. So let's keep it. Let's continue.
Yeah, let's continue. Run.
Yeah. So after you click the running, it will give you this empty blank.
Yes.
But we can leave it empty because it's the default API URL is this one. So it's correct. We can press enter. So it will show another one. Did you get it?
Yes.
Okay, here we will going to use the API key. So we go into our profile. Yeah. And open the CDS. Yeah, just click copy this API key, this one. So we click copy and then we paste here and press enter. Okay, so you can see, did you have? So our request is automatically, it's already sent to the data store. Yeah, it's already sent to the data store and we don't need to click in the download page. So we need to just wait for the data store to process our request. In general, it will not be that long. Let's see. Sometimes and also you can check your request here. Because in here, we can monitoring our request. So you can see here, this one is our submitted one, so it's still query. We still need to wait. They are not in progress. Maybe yours is already completed.
Yeah.
Okay, because I think I need to delete this one. Okay, let me wait. Because when I show you the example for downloading in the website, I submitted one. So maybe that one make me. Okay, so now the status updated to running. So let's wait. Yours is already ready as well.
No, it is successful.
Yeah, okay. So let's wait. Wait for my running.
Okay.
Okay, I think now it should be completed. Because we only send a request for one day, so it should be quick. Okay, now it's successful. So, but the cell is still running. Oh, okay, here we are. So now we already load so here is the variable we are named. So we name it source in. So the window data from the source. So the data is already in this variable. We can have a look what this variable looks like. So we run this cell, source wind. So it shows us a next for failed list reader. So show this one, you don't need to understand what it is. It's a type of this kind of objective. So we cannot use this one directly, right? So we will use some functions to transfer this data objective into the format that we can use. So we use the variable source wind. We use a function called to xarray and to squeeze it. to transfer it as a format, as a official XArray dataset. So you can click here to run the cell by yourself. You get the result. Yeah, so for example, yeah, so when I put the variable here, they will print the information of that variable. For example, if I delete it, so they will not, it will not show this result. I can renew, I can insert another cell to see the result. So it's convenient. You can put it in the last line, so it will print it directly. So you will see what this variable looks like. So it will print all the information within this variable read wind. So you can see the type of the data here is the XArray dataset. So it will have dimensions. So that's what's the NetCD4. The NetCD4 dataset, the format, they will be a three-dimension dataset. So they will have a time dimension. So as we download the 24 hours, and they will have a latitude dimension. So 14 degrees and longitude 21. So here you can see the time exactly here when you click here. When you see in the coordinator, you can click here. They will give you the detailed information of what's in this time dimension. So 2024, October 16th, from 0 to 23. And with the same, so for the latitude and for the longitude, you will know the coordinator of the special location for each grid. Yeah, and also you can look into the number. You can see the step is 0.225. Yeah, so it's it's the spatial resolution of the error 5, the 25 kilometers. Yeah, exactly. And here you will see the data variables. It's the variables we request. The 10 meters U component of the wind speed and the V component. So the name they write it U10 and V10. So you will know what is the variable. So here, you will not see the number directly because they only shows the shape of the variable. Actually, this type of variable, they are not loaded into our environment because they are still in the cloud. But we can, after we calculate it, it will enter into our space because it will save the RAM. For example, if we have a very large data set, we cannot read all of them into this notebook. For this type of shape, the data type, it will save the RAM. So because they only read it when you are computing it. So it's kind of a lazy loading. So here from the figure, you can see you can have like image overview of the shape of this type of variables. For example, you can consider this as the one single map, one map. For example, the longitude and the latitude. And we have 24 such type of maps because we have 24 time step. Yeah. So here we get the data set. It's already can be used. But this, as I mentioned in this morning, this U10 and V10 are not the real wind speed. We need to calculate the real wind speed based on these two components. So here is a brief introduction about how we use these two variables to calculate the exactly wind speed. So for example, here we have a wind direction from this angle. So this vector represents the real wind. So the V is the real wind speed. And the direction of this vector is the real wind direction. But in general, in the data set, they like kind of transform this direction into a formal direction in the eastward and the northward. So they do the projection into these two axes. So here we get the U component. Yeah.
It's calculating or considering with respect to which axis?
Is relating to this axis, to the north. Yeah. But when you're doing the sine and the cosine, it's similar as this part, or this part, or this triangle. So this 212 is this one. Did you see?
Yeah.
This curve. But when you do the sine and the cosine, it can be because in this, yeah. So it can be Yeah. So it can be projected into the X and Y. So it's actually the eastward and the northward. So they project it into these two axes. So in the data set, we only have these two. So if we have these two, for us, it's easier to calculate this one because we only need to apply this one. Like we do a square of this.
Specific amount of any vectors.
Yes. So we only need to apply this formula.
Yes.
So we will get the magnitude of this wind speed. And also we can have this angle, like the real angle. So the wind, the real wind angle the wind is came from. So but all the figures here, you can click, it will direct into the formal page so it will give you a more detailed description here, like what is the mathematical law behind this formula and how to calculate the magnitude and also the direction. So here, if we understand how to calculate by these two variables, as I mentioned before, in this package, it's called MatPy. It already have the function to calculate the wind speed. So they already wrote some codes to calculate this formula and also the direction of the wind. So what we need to do is just to import this function as MatPy calculation. Also, you can change the name here. Yeah, you know. And then we use this function and use the calculation of wind speed. So the function called wind speed. And then we use the wind U and V component. So it's what shows here. So the variable here. Yeah. So when we use the variables from the net64, we can use this dot. So here you can see we just use a dot. For example, I can show you here. When I write this grid wind U component, the dot, it will select the time series of the U-turn component. Right? You understand? Okay. And another way is to do like this. We can use this way to select this variable. All right. Okay. I always have to program. I think it will have the same meaning. So there are two ways to select the time series. So now you may notice, now it's not a data set, it's a data array. So this data, what is the meaning of the data array? It's already an array of what's the wind speed. It's the time series. It's already the array of this variable. But so in this data array, we only have U10 because we only select U10. And we can also select V10. We can have a look. So it's the same. We only have the V10. But in dataset, so you can see here in dataset, we have both of them, but we can not calculate them based on the dataset. We need to select the exactly area to pass it to this function, because they only know to calculate it by passing the U component and also the V component. So if you have the data area of these two components, they will calculate the exactly wind speed. So here we will have this one. And for this slide, we will like give the wind speed a unit. So we will like give them a unit of meter per second. So, and then we will show the wind speed. So we can have a try, we click on the running. Here we have. So it will show the wind speed. So now you may notice that the data area, it has this like a random name because we didn't give it a name. We can name it, but we don't need because for sure we can, yeah, it's not necessary. So here is, we don't have the U component and the V component anymore. So it's the exactly wind speed. And we have the units here. Yeah, but you can see that the spatial resolution is the same because we calculate the wind speed based on the same format, the same spatial range. So they will return you a value as the same spatial resolution. You can imagine before we have this kind of shape, and in each grid we have a U and we have a V. So after the calculation in that grid, we transfer these two variables into a wind speed, but we didn't change the grid. So we will have the same grid. Okay. No, so far it's okay, it's clear. Okay. So here I will give you some small note for transfer the unit because because when I preparing the materials, I find in different websites they use different units for the wind speed. In general, they use this mile per hour, kilometer per hour, and meter per second. So it's some definition. So 1 mile is this equal to these meters, 1 hour equal to these seconds. Therefore, we can transfer 1 mile per hour into meter per second, and 1 meter per second to kilometer per hour. So we don't need to remember these numbers because I already put them there. So when you need to transfer these units, just check here and then multiply it. So it's just a quick note for you to check to transfer the units. Now we already knew how to calculate the wind speed. I will introduce you a concept because when I don't know if you ever have a look into the windy or some forecast about the wind speed. Maybe not, because we never care about the wind speed in our case, in our daily life case. So we can click here to have a look of the windy. So it takes some time. Also this one. So I selected these two websites. They provide some weather forecast in the Strait of Messina. So there are two websites. One is called Windy, and another one is Fishing Points. So for example, here for Windy, we can see they provide some statistics about the wind history. For example, here they provide until 2024, I think. from 2012 to 2024. We can see here from the daily wind speed and also the temperature there. And here, what I want you to have a look is, so for this one, we know it's the wind speed. But you may notice here, there is another number, the called gust. So it's not ghost. So if I pronounce it correctly. So what does this number mean? So what is this speed? So that's what I'm gonna to introduce you. Also, we can have a look of the fish point. So in the fish point, we will have a look of the. So here, the same. Okay. So we have a wind speed here. And we also have a wind gust here. So what is this? What is this number? What is this gust? What does it mean? How we calculate it? So so here, we notice that there is a wind speed called gust. And this speed is calculated by multiply the mean wind speed and with this factor. It's called Gunst factor. And what it measures? It measures how much a short duration peak, so the term is called Gunst. So it means the short-term peak. Imagine, because now we have data time series of hourly data. But what happens within this hour? We don't know. What's the wind speed, for example, within these 3 seconds? We have no idea because we not only have the information about the hourly data. So here you can see the short-term averaging is the Gunst, is the above part, is the number of the Gunst number here. And what we have is the long-term average, is the hourly. For example, we have a 1 hourly number here. Yeah. So the Gunst factor is not a fixed number. It will be different in different location, different time, different height of the wind speed. So with our hourly data, we cannot observe the 3-second Gunst. And we should use a model or parameter estimation. For example, if there are some like ampere experiment estimation of this factor, for example, based on the past wind speed. They were told me, like in this Strait of Messina, the Gunst factor is, for example, 2. So now if we have the hourly wind speed and we have estimation of the Gunst factor, we can estimate the Gunst wind within 3 seconds. So we just multiply the Gunst factor. So we can convert the hourly means to a short duration of Gunst. So here you can see this is the formula. Like if we have this factor, we can multiply with our hourly wind speed. And then we will have an estimation of the Gunst speed. So why we should consider this Gunst speed? And why we already have hourly mean is not enough, and we should still consider this Gunst. Like we can imagine, we are a fisher in the Sicily Island.
Okay.
Every day we will check the weather forecast to decide if we going outside, going to the sea to do some fishing activity. Because if the wind is very strong, for sure it's very dangerous. So in general, if the weather forecast, they give us the hourly forecast. For sure, it's very important information. We will know what will happen in the next few hours. But what might happen is that, for example, if they told me the wind speed is 5 meters per second with the average within next hour, it looks safe. But on the sea, in some short duration, for example, in some 3 seconds, when we are on the sea, there might be a much stronger wind than the 5 meters per second. That's why we need to estimate the short duration of the ghost. We also need to know the very extreme condition within a short duration, because it might happen. Because the hourly forecast is in general the average within all the seconds. Like if we separate the hour into the seconds, it's the average of all the seconds. So it will narrative the real range of the wind speed. For example, within that hour, there might be some value lower than the mean. There might be some value very higher than. So that's what we will use this constant factor to estimate. So for example, if one forecast shows the ghost up to 3 meters per second, and they also shows the average wind speed is like, for example, from 1 to 3. We can estimate the ghost factor there, like it's between 1 and 3.05, because we use the ghost value divided the mean value. So here, for example, here, if we have a ghost like 8.9, and we have a mean of 6.7, we use 8.9 to divide this. We will have a ghost factor for this time step, for now, for this time step. So as I mentioned, it will vary across the time. Because for example, when you look into the around this like midnight, no, around the noon, from 12:30 to 1, the ghost speed is around 10, and the factor is much larger. So it has the physical meaning, like there are some time steps. The wind are stronger, and the extreme wind maybe has the higher probability to occur. So we should take into account that this is not a fixed value. So, and we can estimate it like across different times. So this is the concept of the Gunst factor. And for sure, it's important for our case study of the Strait of Messina, because when we design the bridge, we also should consider this kind of short-term peak of the wind speed, right? But in the following section, following analysis, we will not like calculate this ghost effect, because it's not the goal of this study. The goal of this exercise of this case study is to show you how to calculate in general the mean wind speed, not the ghost one. But this concept is important to know. So just to introduce here, and you can find detailed like description when you look into the notebook. Okay, so let's move forward. I think we have still 10 minutes, more or less. Okay. So,
If you think it is take more time, then we'll continue next session.
okay, but I can give you a very brief introduction here. So in general here, we already calculate the mean wind speed, right? And now we already have the result. We want to visualize it because if we don't visualize it, we cannot analyze the result. So here we import some packages, some libraries for visualization, and keep into mind when we visualize this type of data set, we need to select one time step. Because if you directly plot the map, it will raise an error. Because as we introduced before, the data set is exactly 24 maps. So we can only visualize one map per one time step. So here I use an example of like time at 0. For sure, we can modify the time here. Modify to 1 hour, for example, and until 23. And then we select these two variables, like here, the U component at that time step, and the V component at that time step, and also the wind speed we calculate at that time step. We name into this. So here, why we still need these two? Because we need to plot the wind direction. So the wind direction information is still stored in these two components, right? So we have the wind magnitude in this wind speed. So
is magnitude.
what's the 80?
DA equals. Yeah, that's.
Yeah, the DA. Because also the DA, you can rename it.
It's the magnitude just only the velocity.
It's because it's what we calculate in the wind speed. So it's this one. It's from this one. Yeah, from this one. You see here, it's from this one.
Okay.
And then we select all this one. We set in the plotting format, like the font size, the grid, the subtitle. You don't need to be like fully understanding this part. It's not necessary for modification. You can use it directly. Yeah, it's just for look better, more beautiful plot. Okay. So here we will need every time when we create a map, we need to define a projection. As the same as I showed you in the atlas this morning, we need to choose a map projection. So we choose this map projection, and based on this map projection, we create a feed, an empty feed. And then we will start to add different component into that empty feed. For sure, for example, here we add some coastlines. So the coastlines of the South Italy. And we add the country border of Italy. Actually, these two is the same. Because in the south part of Italy, the coastline and the border is the same. The Sicily and that region the same.
Yes, same.
And then here we create the longitude, latitude grid for plotting the wind velocity.
Yes.
So we use the value. You can see here is the wind speed. We use the value from the wind speed to create the grid, to plot the grid. And then we add a color bar to illustrate the wind, the color and the number, the relationship between the color and the number. And then here, we will add some quiver. What's the quiver? It's the quiver which shows the direction of the wind.
The vectors.
Yeah, the vector shows the direction of the wind. So here we use the step. So it's just adjust the density of the quiver. So I give you the example. So here is, if we select 2, the vector will be more dense. So there will be more vector. If we select 4, it will be less. So you can change it. You can change it here. And so we also create a latitude and longitude grid. So here you don't need to modify anything. And here so here you can see we will use the value from the U component and the V component of the direction. So here, and because the function of this quiver, they can directly distinguish the U component direction and the V component direction, and they will transfer it into the real direction of the wind on the map. Okay, so also the other part is like for adjust the shape of the vector, the width of the vector, the head width, so for visualize. And then also we set the map extent. We set it to the extent of our study area. So it's from 13 to 18 and 36 to 40. So, and then we will have a grid, a point, the point location of the bridge. Where we will build the bridge. So to see where is the location within that strait. Then we plot the point. So just plot a circle, a marker into this location, the longitude and the latitude. And then we add the text for the bridge to better illustrate, to better visualize. And here is also the format static, and then is to set a title and to show the figure. So in general, all this cell is to visualize the wind velocity, wind direction, and the location of the bridge. Okay, so we can try to run this cell. Okay, you already run it. Okay. So it will show you, we can ignore this kind of warning, but warning doesn't influence so we can get a very nice map very quickly. So we will have for example, the color here represent the wind speed in that grid. You can see here a lot of grid because the resolution of the data set is 25 kilometers. And here we have a relatively small range. So the grid will seem very large. You can distinguish the grid here. Like each grid have a value, have a different value. So the darker the blue, the larger the wind speed. And we can also see the direction, like where the wind came from, where it blows to. So for example, if we look into the bridge, we will see the wind is blow from the south part, like from South Africa to the northwest. Yeah, to the northwest. But keep in mind, it's the direction and the wind speed at this time step, only at this day. So this map is only for last year and time zero. If we change, for example, if we change this into 2, we rerun this cell, it changes.
Exactly.
But the direction seems similar, but the speed changes. So you can try it by yourself. After the lecture, you can modify it for all the hours. Or you can try to download data for a different day, for the day you are interested. And then you can try to plot this figure.
Thank you.
Okay, I think we can stop now for today. Yeah.
Thank you.
No problem. Thank you because you are only student. We stopped. Which one is the stop? I don't know.